Good morning, ladies and gentlemen, and welcome to our review video. After meeting with y'all the past day or two and starting to talk about fractions, I realized we needed a little more in-depth on the background and the whys of fractions. So we're going to start by talking about creating fractions and the meaning behind them. So when you're talking about fractions, you're talking about parts of a whole. So if I have one whole, this can be split into many different types of pieces. We are going to look specifically, with this example, at thirds. So I can have 1/3, 2/3, and 3/3. Now in this case, 3/3 put together equals one whole. And we could also determine the fraction based on different aspects. I could say, what fraction of this strip is yellow? Well, yellow would be 1/3. If I asked what fraction of the strip is not yellow, I have 2 pieces that are not yellow out of a total of 3. So we need to understand some vocabulary. A numerator is not only the top number, but it is the number of pieces. And then your denominator is the total number of pieces. So if we're looking at this example for our thirds, if I asked what is the fraction that is not yellow, what is the fraction of non-yellow parts, I know that I have 1, 2 that are not purple, so that's going to be my numerator, 2 that are not yellow out of 1, 2, 3 pieces in all. All right, so that's just some basics. You also need to realize that 2/3 can be written multiple ways. So let's move this. 2/3 can be written as a fraction this way. It can be written as 2 out of 3. It can be written as 2/3. Or 2 out of 3. So when you're reading information, make sure that you're looking for all of these different types of ways that the fraction's name could be written. All right, so let's move on. The next piece that we are going to be looking at is comparing and ordering. A lot of students learned the cross multiplication strategy to compare fractions. And while yes, cross multiplication does work, most students don't know why. And if they don't understand the why behind it, then it's a trick and not a strategy. So let's start by looking at a fraction that the pieces, the total number of pieces are equal. So I'm going to fold this in half. One side of this is going to be for like denominators, and the other side is going to be for unlike. And unlike. Okay. So if I look at the two fractions, 4/6 compared to 2/6, I'm comparing apples to apples because I have two fractions with the exact same denominators. So the pieces are the same size and the individual pieces are going to be the same size as well. So let's take a look at this. If I have 4/6, 1, 2, 3, and 4. And then I need to compare it to 2/6. 1 and 2. Looking at them visually, I can compare them because the pieces are the exact same size. It makes sense to do so. So in this case, I don't have to change anything on my fraction. If the denominators are the same, then all you have to do is compare the numerator. And in this case, 4/6 is greater than 2/6. Same concept. Let's look at, let's see here, 5/8 compared to 6/8. And once again, I can grab my fraction pieces. One, 2, 3, 4, 5. Color doesn't matter. And 1, 2, 3, 4, 5, and 6. I just need to make sure that before I start comparing that I line them up. And in this case, we can clearly see that 5/8 is less than 6/8. Easy peasy. Now let's start getting into something that's a little more difficult, that we need to start thinking about the whys behind that cross multiplication. So I'm going to clear out the mess that I've made here with all of my fraction pieces. And now we're going to look at these unlike denominators. The first problem we're going to focus on is comparing 5/8 and 2/3. Well, I can very easily pull out my fraction pieces, and you're probably thinking, well, Ms. Pike, this shouldn't be a problem, right? Well, let's see. I have 1, 2, 3, 4, and 5. Compared to 2/3. 1 and 2. But here's the problem. If the pieces that you're comparing aren't the same size, you won't always have this, because you're not always going to be looking at fraction pieces. Maybe it's a fraction that represents the number 5 students out of 8 in a small group. understand the concept. Or 2 pencils out of 3 are sharpened. And in that case, you're not comparing apples to apples. Comparing the number of students to comparing the number of pencils doesn't make sense. So this is when you have to understand how to create fractions with like denominators in order to compare them correctly. So in this case, we're going to start with the traditional strategy of using the least common multiple in order to create a new denominator. So we're going to be multiplying or dividing these fractions somehow, technically multiplying, in order to create new fractions that have the same denominator. So I need to list the multiples of 8 and the multiples of 3. 16, 24, 32, 40, 48, 56, 3, 6, 9, 12, 15, 18, 21, 24. Okay, now I'm looking for the smallest multiple that they have in common, which in this case is going to be 24. And then I need to think to myself, well, how did I get that least common multiple? Well, in order to turn 8 into 24, I would need to multiply by 3. In order to turn 3 into 24, I need to multiply by 8. Well, why make this harder on ourselves than we have to? If we're just crossing the denominators and multiplying the denominators by each other, well, we can do that without having to list the common multiples. Let's make it easy on ourselves. So in this case, I'm going to grab 2 other pens here. I'm going to multiply 8 times 3. And whatever you do to the denominator, you have to do to the numerator, which means I'm also going to multiply this 2 times 8. And then if I'm going to do that, then I need to turn around and I need to multiply the 8 times 3. Whatever you do to the denominator, you must do to the numerator. And so now we can use this to create our new fractions. 8 times 3 is 24. 5 times 3 is 15. 3 times 8 is 24. 2 times 8 is 16. Now we're comparing apples to apples. We have the same number of pieces, and the pieces are now the exact same size. So if I have 15 over here and 16 over here, that means my 16 24ths is going to be greater. Now, most of you are thinking, well, Ms. Pike, this is a lot in order just to compare a fraction. And you're right, because there is an easier strategy, but only if you understand why that strategy works. And it's cross multiplication. Cross multiplication asks you to multiply the denominator of one side by the numerator of the other. Okay, so in this case, 3 times 5 is 15, and 8 times 2 is 16. Now, if you're thinking like I'm thinking, you're noticing, hey, Ms. Pike, we've got a connection here. Because when we created these new numerators and denominators up here, these numerators now match what we created in the cross multiplication. And that's why this strategy works, is because it shortens the steps that you would take in order to do this. So instead of having to list the least common multiple, find the least common multiple, multiply both your numerators and your denominators to create a new fraction, and then compare them, you're essentially saying, well, I know to create these fractions, I would end up multiplying my denominator of this fraction by the numerator of the other. So the new numerator would be 16, and I would be multiplying the denominator of my second fraction by the numerator of my first fraction, which would end up with 15, which is exactly what we ended up with when we created the equivalent fractions by multiplying the denominators by each other. So that's why it works. Okay. All right. Next piece. Last year, you also would have learned about ordering fractions by using strategies like cross multiplication. Now, we've talked about the why of why cross multiplication works. So now that we know the why, now we can use this strategy effectively. So, comparing to order. All right, so I'm going to list out some fractions. I have 2/3. I have 5/8. I have 9/12, and 1/2. I need to put these in order from least to greatest. So I'm going to start by comparing them. I'm going to compare 2/3 to 5/8. I'm going to compare 9/12 to 1/2. Okay. 3 times 5 is 15. 8 times 2 is 16. That means that 2/3 is greater than 5/8. 12 times 1 is 12. 2 times 9 is 18. That means that 9/12 is greater. So now I know that 2/3 is going to come before 5/8, and 9/12 is going to come before 1/2. Now I'm going to flip these second numbers so that I can compare them. So I need to compare 2/3 to 1/2 and 5/8 to 9/12. 3 times 1 is 3, 2 times 2 is 4. So 2/3 is greater than. 8 times 9 is 72. 12 times 5 is 60. So 9/12 is greater. Now I have to use a little bit of mental organization in my head. I know that 2/3 is greater than 5/8. Do I know how 5/8 compares to 9/12? No. So I also need to compare 2/3 compared to 9/12. 3 times 9 is 27. 12 times 2 is 24. So in this case, 9/27 is greater than 2/3. Okay, so let's start trying to do this out. So I know that 9/12 is greater than 2/3. Okay, so there's one piece. Now I'm going to look at 5/8 and 9/12, which we did here, and we said that 9/12 was greater. Did I compare 9/12 to 2/3? Yes. Well, in this case, 9/12 was greater than 2/3, which we've already got here. I'm sorry, 5/8 was less than 9/12. And And then we also figured out that 2/3 was greater than 5/8. So now I just need to figure out where my 1/2 follows in. Was 1/2 greater than 9/12? No. Was 1/2 greater than 2/3? No. Now we need to compare 1/2 to 5/8. 2 times 5 is 10, 1 times 8 is 8. In this case, 5/8 is greater than 1/2. Okay, so just to make sure, 2 times 12 is 24, and 3 times 9 is 27. Okay, so that's good. 3 times 5 is 15, 8 times 2 is 16, so that's still correct. 8 times 1 is 8, 5 times 2 is 10. Okay, so I do have them in the correct order, which means that the correct order from least to greatest is going to be 1/2 is less than 5/8, which is less than 2/3, which is less than 9/12. Now, you may have to do some more comparisons than this, but you also might be able to say, well, I know that 1/2 is less than 2/3 because it's a standard comparison fraction. So I would know that this would have to come before that anyways. And I know that 4/8 is half, so 5/8 is going to be bigger than that. And I know that 6/12 is half here, but 9/12 is going to be greater. So ultimately we know that all three of these fractions are greater than 1/2. So you can use the mental math or you can work it out this way. Either way, as long as you understand how to use this skill in order to compare and order decimals. Or not decimals, fractions. Fractions. My brain's been stuck on decimals. All right, well, I think we've covered enough in our Fractions 101 review this morning. I hope that this was informative. I hope that this gave you a good review of skills that you would have learned in the past. And we will see you next time. Bye, guys. Have a great day.